is formed by two rays of the same endpoint. The rays that form this angle would be SR and ST. And that, I have to say ray ST, ray SR, and we'll put the little baby ray over it. That's how we name rays, right? They have to have that common endpoint. So this same endpoint is also called the vertex. So it's the vertex that there's only, well, it's the vertex. So this angle is the degrees that fall in between here, right? So from here to here, there's a measure of degrees. We can name angles multiple ways, like we can name planes in multiple ways, like we can name lines in multiple ways. That's what we're going to talk about. We can name our angle by vertex if it's the only angle at the vertex. Remember, the vertex is that endpoint that those sides share. So these rays are the sides of this angle, they share this endpoint S. So we could name this angle as angle X in this case. And that's if it's the only angle at the vertex. Another way we can do it is we can use 3 points. Do 1 point on each ray and the vertex. So the vertex has to go in the middle. So we can name this angle RST or angle TSR. Because while there's not a dot, that S, that is a point. Where those two rays intersect at the end point, remember. So we could name that angle that way. And there's this little symbol. Not exactly right. So I'm using the left-hand symbol. Technically, the angle symbol. So like we have to have a little baby line over a line when we name it, a little baby ray over a ray when we name it. This is an angle symbol. It's like a little baby angle. Technically, it should look more like that, probably, like flat here. So that is read as angle S. This is read as angle RST or angle TSR. The location of these points and how we name the angle means something. That middle point is always the vertex. Okay, that middle point is always the vertex. And sometimes they will just label an angle with a number 4 and make it a little bit easy for us to name it. So we could also, if they put a label there, we could also call that angle angle 2. Any questions on how to form an angle, what the vertex is, how to name the angle? This is that same angle, angle RST. So we've got these two labels, exterior and interior. What does exterior mean? The exterior of your home is the outside of your home, right? Interior of your home is the inside of your home. So there can be points on the exterior of an angle or points on the interior of the angle. Is point Q in the interior or the exterior of that angle? Xavier says interior. What do you think, Amaria? You are exactly right. Not only are you right, you're both right. You explained it perfectly. So in second period, they're like, oh, that's from the exterior. So it looks like it's from the outside of that angle. But remember, these little arrows on the end of the rays, you know, these rays go on forever. So if you extend those rays, that's a really poor ray. But if you extend those rays in that same direction, you'll see the Q is in the interior of that angle. And we should know that, right? So we're going to write interior for the answer to that. It's in the interior of angle F. Now you notice there's not a 2 there anymore. We're not on an angle anymore. We're going to go down angles do you guys see there? How many angles do you see here, Thomas? Okay. How many angles do you see here, Kevin? 2. Amaria? There's 3. Where's the 1, 2? Where's the third? The whole thing, right? So this is angle 1. This is angle 2. The angle is this measure in here, right? But there's also this big angle. Does that make sense to everyone? Bigger? Right? They did not name angles, so we have to name angle ABC with angle AB as angle ABC or angle CBA, right? We can't call any of these angles angle B. Why not? B is the vertex of how many angles? Yeah, so if B is a vertex of more than one angle, we can't name it by that angle. So could you call it no? Because it's the vertex for more than one angle. And I'm going to use that angle symbol. Can you give me another name for angle 2? Can you give me another name for angle 2? Analia? Can you give me another name for angle 2 besides angle 2? Let's look at how to name them. So we can name it by vertex, but we said we can't name by that vertex because it's a vertex for more than one angle, right? We can name it by 3 points. Can we name angle 2 by 3 points? Yes. Which 3 points do you think we could use? Perfect. That would be one great way to name it. Now you have to put the angle symbol. If you just put EBC, you're telling me it's plain EBC, right? So this is angle EBC, or what's the other way we could do it, Miles? CBE, that's right. As long as the vertex is in the middle, we can name it with those 3 letters. 1 point on this side of the angle, 1 point on this side of the angle, and the vertex. Questions? So this is a picture of a protractor. We're going to learn how to read the protractor and measure an angle, kind of using the protractor. We're not going to have to use a protractor, but you may have to use one on a digital one like this on your EOC. Hold on, I got to fix my board. Click to me. Thanks. Okay. So angles are measured in degrees. Do you guys remember that from middle school? And you can use this little symbol to indicate degrees, right? We use degrees to measure temperature, but they're not the same kind of degrees, right? So this semicircle little device is called a protractor, and it's got numbers from 0 to 180 on the top of this arc, and then from this arc here, and then from 0 to 180 going the other direction on the inside. So each of these little marks is 1 degree. If we want to measure an angle, we mark it on here, that is marked on here. We are going to just count or use some addition and subtraction to find out how many degrees are in between each side of the angle. Okay, so angle AOD, angle ABD, FOD would be this angle. So there's a point here, A, follow it to O, all the way up to D. So we can see here, this is a 90-degree angle. It goes from 0 to 90 underneath. That makes that a 90-degree angle. So if we use this 90 on top, on the numbers on top go to 180, so we would just subtract 180 minus 90. I think I forgot to take roll. Let's do that real quick. Okay. This is good. All right, so angle EOC. Look at your paper. What do you think the measure of angle EOC is? Find the side, find E, go down to O, go back up to C. So this is one side of the angle, this is one side of the angle. So the angle goes from here to here, right? Thomas? So let's see. So I'm going to use the bigger number, and then I'm going to subtract. So 120 and 50 are on the point. Did you subtract 120 minus 50, Thomas? That's exactly right. So one way to do that is 120 minus 50. That is a 70-degree angle. Angle FOA. Find your F. Go to O. So the O is the only vertex on this diagram, right? FOA. So that's this entire thing here. So FOA all the way over. But really, we're just looking at these numbers here. So that says 140. I go all the way over here, and this is below that arc. So if I look below the arc, that's 0. So 140 minus 0 is 140. So it's 140 degrees. And angle BOC. What do you think? What is the measure of angle BOC? Morgan, any idea? Okay, well, let's do it together then. Here's B, right? Follow the path. B to O, O to C. Does that make sense, Morgan? So this part here. So from this, these are the two sides of that angle, BOC. So there's a side formed by ray OB, a side formed by ray OC. So how far are those apart? Well, I'm going to use biggest minus smallest. So there's 50 on the bottom and 30 on the bottom. So it's 50 minus 30, which is 20 degrees. Does that make sense? Anybody have questions on the protractor? And if they have angles in there, how do you measure them, Dallas? Because those sides run through two numbers, right? So for angle BOC, it ran through 30 and 50. 50 minus 30 is 20, right? Also ran through 150 and 130. 150 minus 30 is still 20. So you can use either the numbers on the bottom or the numbers on the top. Yeah. If you start at 0 and go up, you can just, like this first one we did, this angle AOD. If we go AOD, you will start at 0 and just count up, right? That's the only thing that starts at 0. Most of these aren't starting at 0. Okay? All right. This should be reviewed. How do we classify angles by their measure? And when we say measure, we don't have a link for angles, right? We measure them in degrees. So we don't know how long they are, which we measure them in there by the number of degrees. What do we know about an acute angle? Definition of acute angle. Less than 90 degrees. Do we know be a little bit more, it's going to be 9.1. It's going to be 89.9. It's going to be exactly 90 degrees. So what do we know about an obtuse angle? More than 90 degrees, there's going to be less than a number. What number do you think it might need to be less than? 180. Perfect. Talking about straight angle earlier in this chapter. How many degrees does a straight angle have? Oh, very good. Down to 180. Remember, it's a line. A straight angle. It's also opposite rays form a line or a straight angle. Remember talking about that. So a straight a line is a straight angle of exactly 180 degrees. And their opposite rays form a line, remember. So a ray, if we had a C here, we could this ray and this ray would be opposite rays. They form a straight angle, which is exactly 180 degrees, and we are going to call it a line. Because you have to know all these definitions. Okay, congruent. What do we know about, can lines be congruent? Can lines be congruent? No, because they're infinite, right? Can rays be congruent? Or more or less, we can't measure rays or lines, right? I guess in theory maybe they're all congruent, but we don't measure them because they're infinite. But we can measure segments, right? When we measure segments, we're measuring their what? Yeah, their length, right? So distance, which is their length. But for angles, we're measuring their degrees. So congruent angles have the same measure, which means the same number of degrees. So that little symbol is for degrees. We learned this symbol for congruent in the earlier lesson. Remember, it's this little squiggle, like an equal sign underneath it. That means congruent. We learned that we can mark segments as congruent with little dashes. So we have to know now to mark angles as congruent. For instance, here, this arc and this arc, since there's an arc, one arc on each of these angles, we know that these angles are congruent. So angle 1 is congruent to angle 2. And we know because same number of arcs marks means they're congruent. So the same number of arcs indicates they're congruent. Figure. It means if angle 1 is 30 degrees and angle 2, if the measure of angle 1 is 30 degrees, the measure of angle 2 is also 30 degrees. Doesn't mean they're exactly the same angle though, right? Right. Yeah, so we can't measure a line or a ray, so we would not indicate that they're congruent or not congruent, right? We wouldn't say the one is that they have the same measure, we wouldn't say they have a different measure, we wouldn't measure them. Okay. So now we need to use this information to be able to name angles. We should be able to figure out the size of angles from the sides that form angles are rays. So when we name the side of angle 1, what are the sides of angle 1? What are the sides of angle 1? Can you give me what the sides, Charlie? Angle 1, mark right here. BC would be one side, yep, and it's ray BC. So don't forget, ray BC. How much was the other one? BA, ray BA, very good. Could I name that ray AB? No, right. These are the sides, they have to have the same endpoint. They have to share that same endpoint. Carla? DE? No? So remember what forms an angle. So let's look at this example we just did. So this is angle ABC with that point. What would the sides mean for these? Okay, closer. What are we going to start with? Got to start with the vertex. We're going to start with the end point and the side. Yes. So now what is the artist? BC is one side. Ray BC. And what's the other side, Hannah? BE. Very good. Ray BE. Can we give another name for angle 1? Elizabeth, can we give another name for angle 1? Beautiful. Angle ABC. ABC. You don't forget your angle indicator, right? If you just tell me ABC, I can get it wrong. That's plain ABC. You have to put your little angle symbol. All right. Adine, can you give me another name for angle 2? CBE. Very good. Angle CBE then, right? Let's not forget the angle mark. Very good. Angle CBE. That vertex has to be in the middle when you name the angle. Basically, where do the sides meet, or where do the angles turn? Where does the angle turn? However you want to think about it. Okay. So we've already discussed that there are 3 angles. Well, it was a different one, but this is, I think, the same picture. There are 2 angles marked. Zaria says there's 3 angles, and Zaria we confirm was right. Right? So there's this angle ABC. There's this angle CBE, and then there's a bigger angle ABE that's formed by Ray BA and Ray BE, right? So if this angle 1, just real quick, if this angle measured 20 degrees and angle 2 measured 10 degrees, how much do you think a whole big one would be? 30 degrees. We just add them up, right? So whatever angle the measured angle 1 is, we add it to measured angle 2, that equals that bigger angle that contains them both. You can think about that angle ABE as being divided by this Ray BC and creating 2 more angles, right? So when we add, just like the segment addition postulate we learned about, if you add an extra point in the middle of 2 endpoints, you create 2 parts of that one segment we started with. You add the length of one to the length of the other. The 2 parts give you the whole, right? It's the same thing here. You can think of angle 1 as part of the big angle, angle 2 is part of the big angle. If we add those together, then they equal the whole big angle. One thing we need to talk about really quick, that M, what does that M mean? You read that M as the measure of. So that's how we read that, the measure of. So one of the things we're going to note here is that the measure of angle 1 plus the measure of angle 2 equals that whole big angle. So we're looking at them given as expressions that represent the measure of certain parts of the angle. And then we're going to use those expressions to solve for x and then to find the measure of angle 1. So let's make a note that the measure of angle 1 plus the measure of angle 2, we said equals the measure of that whole big angle ABE. And the writer's in space here, so we're going to work around that. So we're going to work example 12, finish it right here. So for example 12, we're just going to replace the parts of that and kind of just give ourselves a formula, right? If we could write an equation based on the measurements of the parts in the whole angle, then we can of angle 2? Well, they tell us that's 7x minus 2. So we can plug that in. Got to be equal to the measure of that big angle, ABE, and they tell us that's 52. So now we've written an equation. We can solve for x, because we need to know what x is, and then we need to use that to find the measure of angle 1. So we're going to solve this equation, combine our like terms, 10x plus 2 equals 52. We're going to subtract 2 from both sides. 10x equals 50, and I'm going to divide both sides by 10, and x equals 5. That's part of my answer. The other part is to find what is a numerical measure of this angle, and we're going to use this expression. So the measure of angle 1 is equal to 3 times our x value of 15 plus 4. So the measure of angle 1 is 19. Any questions on that? Now we're going to use the same diagram with different expressions for the measure. For 13, we're using the same three angles. They give us a different expression to represent the measure of angle 1, 2, and ABC, but we do it the same way. Xavier? 62 is given. Right here. So we solved for x and got 5. That's how many fifths? Right. And then up here it tells us the measure of angle 1 is equal to 3 times whatever x is plus 4. So we knew that we could replace x here with 5. And so 3 times 5 is 15 plus 4 is 19. Okay? And now we're going to do the last example. Example 13 will be right here. So we've got to find x and then say if these two are congruent. I'm telling you, the only way to tell me if these two are congruent is if you find the measure of both of them. So don't find the measure of one, or don't just say yes. You got to show me the work for finding the measure of both, and then tell me yes, it's congruent, or no, it's congruent. If you get the same number, are they congruent? Yes. If you get different numbers, they're not congruent. But you got to show the work and then explain what the work tells you. Be careful. I know some stuff second year, you guys assume that these expressions for the angles were kind of the same, and they're not. They're always double check. They do switch things up and use the same diagram a lot. So we're still going to use our little formula we came up here though. The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABE. So it's a little bit different here. So for 13, the measure of angle 1 is 4x plus 5. Plus the measure of angle 2, well, for number 13, that's 6x minus 7. And it's equal to the measure of angle ABE, and number 13, they tell us is 7x plus 13. So now we're going to combine like terms, get our variables on the same side, solve the equation for x, and then use that x. So 4x and 6x is 10x. 5 minus 7, negative 2, equals 7x plus 13. Get our variables on the same side. We can subtract 7x from both sides. That's 3x minus 2 equals 13. And add 2 to both sides. And I'll get 3x equals 15. Divide both sides by 3, and x equals 5 again. So that is part of my answer. So now, what is the measure of angle 1? What is the measure of angle 2? Are they congruent? That's what we're going to figure out. So use the expression, tell us when we plug in that side 5 again, and now we're plugging it in for the expression at number 13. So it'll be 4 times 5, that's where the x is, plus 5. So the measure of angle 1 is 25. Use this expression here for the measure of angle 2, or replace the x with 5, so that's 6 times x with 6 times 5, minus 7, that's 30, minus 7 is 23. So this is what you must show. Are they congruent? They are not. No, this is 25 does not equal 23. So your answer, the things I need to know, x is equal to 5, measure of angle 1 and measure of angle 2 are not congruent, but all this work has to be shown. I am doing something I've never done after 15 years. I'm grading your homework assignments as a percentage of completion rather than just taking big chunks off. So if you have 20 problems and you do 10, and you should work for all 10, you get a 10 out of 20, which is a 50, right? But if you give me an answer for all 20 problems, but you only should have worked for 5, you're going to get a score of 5 out of 20, which is 25. So everybody understand that? You have to show work for your types of problems. Y'all can scan and submit these. I think we're done. If you have any questions. And then you're going to look over to that real quick. Let's talk about some of the notation on the back. And then look at number 20, just so you know what they're asking here. It gives you some information, but that statement for number 20 says angle FXG. What is that little symbol next to it? FXG. Congruent, right? This says angle FXG is congruent to blank. So angles can only be congruent to other angles. So you're looking for the angle in that picture to the right that is congruent to angle FXG. Does that make sense to everyone? Okay. So scan and submit, and go ahead and get started on your worksheet. What do you think? Get started right now? Okay. Let me pause my recording or cut my recording. It's been going forever.